Welcome to MyProjectBazaar.com. Let me discuss about the process. Monitor placement to timely detect misinformation in online social networks. Let me discuss about the abstract of the project. Evaluation the spread of misinformation, disinformation and propaganda in online social networks. Analyzing online social networks to identify metrics to infer cues of deception will enable us to measure diffusion of misinformation. An algorithm to effectively detect deliberate spread of false information, which would enable users to make informed decisions while spreading information in social networks. The computationally efficient algorithm uses the collaborative filtering property of social networks to measure the creativity of sources of information as well as the quality of news items. The acceptance of misinformation or misleading information by the people depends on their prior beliefs and opinions. People believe things which support their prior thoughts without questioning them. Decision making out of ignorance is often based on heuristic, and the level of confidence on the decision is also low, making correction easier. Such decisions are often correct and are generally not catastrophic. False beliefs based on misinformation are held strongly and often result in great support for a cause. Such beliefs are also very contagious in the persons makes efforts to spread them to others. The spread of misinformation is a result of cognitive process by their receivers based on their assessment of the true value of information. Acceptance of information is more the norm than otherwise for most of the people. When people evaluate the truth value of any information, they take into account four factors: monitor placement problem and prove its complete hardness is used for placement of monitor set. Let me discuss about the flow diagram for our process. Initially, the online social networks, this data collection has been performed. Data collection movement tractor is an approach for extracting short textual phrases from web documents and then tracking how such phrases spread over the web and how they change and evolve as they spread. Meme tracker data contains two datasets: phrase cluster data. The data contains all variants of different phrases and corresponding URLs with timestamps where these phrases appeared. Raw phrases data. The data contains time-stamped phrase and link information for news media articles and blog posts from 1.5 million different blogs and news websites. A collection of raw blog posts and news media articles collected by Spin3 or and released as a part of International Conference on Weblogs and Social Media. ICWSM online news document data includes mainstream news, media articles and blogs. A collection of web crawls from Stanford Info Lab. The web crawls go almost 10 years back. BKFRAC contains ranking made by the subjects of how frequently they interacted with other subjects in the observation week. Next, the misinformation nodes are detected. Detection of misinformation nodes are performed using influence sort method. Misinformation which is initiated from the set of attackers can only spread out a larger population by exploiting the connections from the activity nodes to their neighbors. U3 is a source of misinformation that initially activates U5 and U5 next activates U6 and U8 from the set of victims. Next, U5 can in turn be either the victim of U3 or an attacker itself. U3 has to be an attacker since there is no active node that can possibly influence it. This merged process in turn traces back to U3 and finally identifies U3 as an attacker. Since U3 has no direct link from active nodes, the real situation of course is much more complicated and challenging to track back the attackers, since each active node can either be an attacker or just simply influenced by one of its neighbors. Next, find the path between misinformation propagate and receive nodes. Using shortest path algorithm. Here, Dijital's algorithm is an algorithm for finding shortest paths between nodes in a graph. The algorithm exists in many variants. Digital original variant found the shortest path between two nodes, but a more common variant fixes a single node as a source node and finds shortest path from the source to all other nodes in a graph, producing a shortest path tree. Finally, the monitor node placement will be performed using minimum monitor set construction algorithm. To monitor placement, given a graph, V is a set of nodes and E represents a set of edges. Transmission probabilities associated with each edge and a subset of potential sources of misinformation and a central node R. Problem aims to minimize the number of monitors. Here, finally, we analyze the performance, achieve minimum number of monitor node. In the minimum number of monitor node, we analyze the source size versus monitor size and also number of suspected node versus number of correct node. Let we discuss about the running procedure for our process. Select the main.m file in the controller, right click the file and run for executing this process. Here, we have to select any one graph. This graph contains both number of nodes and number of edges. I selected this graph and this is the number of user deployment. Your path has been generated for misinformation propagate between misinformation propagate node and also misinformation receive node. After performing path detection, we can perform the monitor node placement. After deployment of monitor node placement, we have to analyze the performance graph for our source size and monitor size. This is the graph. This first column represents the number of nodes, node IDs, and second column represents the number of edges. This is the normal user deployment. Here users are deployed randomly. And this is the misinformation propagation user deployment. The red color node represents the misinformation propagate node. These nodes are taken randomly and deployed. Green color node represents the normal user node. This is the path between misinformation propagate node and also misinformation receive node. This is the blue color node represents the monitor node placement. Red color node represents the misinformation propagation node. Green color nodes represent the normal user node. And this is the performance graph for our source size and monitor size. By varying the source size, we vary the monitor size. This is the when del equal to 2, we analyze the monitor size. When number of suspected nodes and also number of corrected nodes, and the number of suspected nodes will be 4 means corrected nodes will be 0. So likewise the optimal solutions using infinite sort method has been obtained. Finally, the misinformation propagate node and detected and place the monitor node between the misinformation propagate and the misinformation receive node. Thank you.